Greetings to everyone. This is a 5 minutes thesis presentations regarding the proposal topic RISC-V best NN accelerator for image recognition. And I'm the presenter today. I'm Kelvin Chong, and I'm supervised by Professor Maya Dr. Oicha. Now we move on to the introductions. What exactly is a RISC-V? RISC-V is actually a new and emerging instruction set architecture, and it has gained a lot of popularity since it debuts in 2010 due to its open source features which allow all ISA which were developed for RISC-V implementations are all publicly available, and the extensibility features allow RISC-V ISA to build for extensions, and modularity allows RISC-V to broken down into various best ISA which can have any numbers of non-standard and standard extensions. Now, what exactly is a NNN accelerator? NNN accelerator is a concept of machine learning algorithms accelerators, and NNN is just one type of machine learning accelerators which are specified for all NNN recognitions. And how is it achieved? It's actually achieved by utilizing the features of extensibilities of RISC-V ISA to extend the instruction set. Now we look into the overview of a RISC-V instruction set, and that consists of a few best instruction set with any numbers of standards or non-standard extensions, and those non-standard extensions are specifically designed to optimize certain operations like ANN in image recognitions. Now, this has been backed up by some of the past researches regarding the RISC-V extensions. In a project entitled "If Going to Crash Down a RISC-V Architecture for Motion Planning Algorithms in Autonomous UAVs," the extensions of the RISC-V instructions architectures for the purpose of faster motion planning in autonomous unmanned aerial vehicles result in collision detections about 5 times faster than professional multi-core Intel processor. And in another project entitled RISC-V Extended Instructions Designed for Multiple Accumulate Operations, MSC, it uses RISC-V extensions on one processor core for MSC operations, and it obtains a result which is about 60% reductions in instructions count and get a maximum 2.2 increments of resources usage in the modified RISC-V core. Now, what is the problem statements for this statement, and why is RISC-V being used extensively in this project context? It's because commercial ISAs are all proprietary. The example being the RISC and CISC ISA, which are owned by ARMS and Intel respectively, and they carefully guide their intellectual properties, and you will need a very high capital cost to get their license to use their ISA. And some commercial ISA come and go, like many once popular commercial ISA have since fallen out of fashion, and they are not even in productions anymore. And popular commercial ISA like RISC and CISC were not designed for extensibility, meaning that currently there is almost no ISA that supports extensibility for general purpose computing systems. Now, the objective of this proposal is to perform machine learning algorithms in C in RISC-V environments through various available toolchains, specifically the NNN algorithms. And the other one is to explore the extensibilities of RISC-V ISA in a Linux environment, and to identify the performance of machine learning operations in RISC-V environments. Now, how is it achieved? For this project context, we'll be using RISC-V GNU compiler toolchains, which is essentially a C and a C++ compiler. And another tools we use will be RISC-V Spike ISA simulators, which provide emulations with HTIF or FSVR, and this is the starting point for running software on RISC-V target. The other tools we use will be RISC-V proxy cannons and bootloader. it allows the running of Linux applications on bare metal target simulator by providing Linux startup environments and emulate Linux system call. And for the context of this proposal, a simple C program has been performed in a RISC-V environment, and we have used the RISC-V tools to simulate these C programs, and we got the output of hello RISC-V, which is exactly what these C programs meant to produce at the end of the programs. So this basically indicates that a very high possibility is that the similar ANN algorithms written in C can be performed in RISC-V environments, and the custom instructions set can be implemented and extended to the current RISC-V ISA, and to perform some benchmarking in the performance by comparing the ISA with and without the custom instruction set extension. So this is the end of the presentations today. Thank you for listening.